All right, hey Wheaton North, Mrs. Trotta here talking to you about the combined gas law. You've practiced some of them individually, now here they are. When we manipulate a sample of gas and we want to make predictions before and after, like we said before, usually it's not just one variable changing, it's a lot. So we kind of need to combine our Boyle's law, our Avogadro's law, our Gay-Lussac's law, and put it all together. So you'll notice your Boyle's law, P1V1, is in here. Our Avogadro's direct relationship is dividing, and our temperature and pressure is also dividing. So all of this together in one formula is called the combined gas law formula. So just a really quick review what all these things mean. P, pressure, V, volume, N is your moles or the amount of gas, T is your temperature. Remember that has to be in Kelvin. You're going to have what that sample of gas is originally, and you'll have measurements for all of these. And then we're going to change a couple of them. So we'll get a new pressure when we change the volume, when we change the moles, when we change the temperature. A couple things that are really important to remember are units. When you are doing a combined gas law, for the pressure and the volume, it doesn't really matter what the units are as long as your P1 unit and your P2 unit are the same, whether it's kPa or atmospheres or millimeters of mercury or whatever your pressure unit is, they have to be the same for P1 and P2. Same thing for V1 and V2. It could be both be in milliliters or they could both be in liters. As long as they're the same, you'll be good. Moles of gas, only one option. It has to be moles. And remember we said before, every single time you do a calculation with a gas law, your temperature has to be in Kelvin. So we'll be adding our 273 to our degrees Celsius. All right. Whenever you're doing a problem, you need to make sure you know what your variables are. As soon as you're given a second version of all of these variables, or you'll know that you'll be using your combined law formula. I'm going to show you how to adjust it to simplify it a little bit, and then you can plug all your variables in and solve. So those are the steps you're going to follow every time you do a problem from now on. All right, here's our sample problem. I initially have a gas with a pressure of 12 atmospheres, 23 liters, 200 degree K, and I raised the pressure to 14 atmospheres and increased the temperature to 300 K. What is the new volume of gas? So we're going to take our 12 atmospheres, 23 liters, and 200 Kelvin, and that's what we have initially for our gas sample. And then it says, then I raise the pressure, so I have a new pressure and I have a new temperature. What is the new volume of gas? So these are the variables in my problem. You'll notice that it said nothing about the amount of gas in my sample. If it is not mentioned, or if the number doesn't change, that means it's being held constant from the initial to the new sample, or the new version of the sample. If it doesn't change or it's the same, I'm going to be able to cross that off, and it's going to cancel in my formula, so I don't have to include it into my math, so I can cross it off. So when you are doing your problems for me, you need to write your adjusted formula down with the variables that aren't changing not included. After that, I need to see all of these numbers put in here in the same order. So P first, then V, over T. Don't change it at all. Show this work. Not showing this work, if you make a mistake, I'll have no idea what your mistake is, and you'll be bumped down to a beginner, a level 1. You're still beginning, learning how to do this. If you can show me this work and I'll notice that, hey, you know what, they've got everything right, but they forgot to convert to kelvins. Or, oh man, they just flip-flop their P1 and their P2, but everything else is the same. You know, maybe that'll bump you up to a developing or a proficient. So show your work so I can see what kind of mistake you're making, if you're making a mistake, and give you a little bit higher credit, potentially. All right, so once you have this out, you can do all the math in your head if you want. I like to just kind of show a little bit. So I would take 12 times 23 divided by 200 gives me 1.38. 14 divided by 300 gives me 0.046. Divide both sides by 0.046 gives me 30 liters for my new volume. So you can see, if I increase the temperature, the pressure goes up. And normally we say if the pressure goes up, the volume should go down, but that temperature seems to be a little bit more important factor involved, and my volume actually ends up going up just a little bit. So it's a little bit harder to make these predictions when you have multiple variables changing, and that's why we use the math to help us make the predictions more accurate. That's a sample problem. You've got a whole bunch of these to do on your worksheet. Remember, write your adjusted formula down, show your work, be neat, always use kelvins. Good luck.